Welcome back to Arcade. I am Super Tommy. This is a series on creating Pac-Man Ghost AIs. Now, in the last video, we created Blinky's AI, which is the chase Pac-Man AI logic. So you see here, Blinky is chasing wherever we're moving as our Pac-Man hero. So we left off in the last video where we created this state behavior AI behavior. And we notice that it's very similar, or there's a lot of code shared between this chase hero AI and our scatter AI. So this is the chase hero. So we get target, we get the backwards, the opposite direction, the order directions, then we have to find the best direction based on the lowest distance. And of course, scatter AI is basically exactly that. So let's see how we can take out all this common code and create one function that does the work, and then we can share it amongst all our different AI behaviors. So we can see that the main difference really is just the target. Everything is the same except for the target. The movement logic is all the same. The target is the only thing that's really different. So let's here, we'll call this, I'll just call this ghost movement. How about that? Ghost movement dot ts, and then we do say determine ghost movement or ghost direction. That is what it's doing. Yeah. Determine ghost direction, and we're going to give it, we'll need a target. So target X, target Y, and then do we need anything else? We probably might. Just use the chase hero. So we need the board, and we need the ghost. Yeah, let's say that. So basically all of this. And let's go here, just paste this in real fast. So we want the target. We will have a ghost, so that's iGhost. Okay, it's not going to help me out if I have errors. So let's see. Utils. So this is position in direction. Just get these imports correct. And then this is from iGhost AI, which is get opposite direction. That's both. And iGhost AI interface. So let's just do this. This won't be this ghost, it's just ghost. Ghost is an iGhost. Oh, sorry. Ghost is an iGhost. Import iGhost from iGhost. Okay. And direction is here. Okay. Tile size. Will you import? Yes, thank you. And then we need to import phaser. I like to import phaser at the top. All right, all our errors. Yep, all our errors are gone. Okay, let's just make sure what we're doing here. Let's fix our formatting. All right, we're going to pick the backwards direction based on our ghost. Good. Going to get the directions we can actually use. Okay. Best direction, distance, the position of the ghost, and then we're going to transform it to the grid X and Y. Go through each board. This is what I'm surprised it not give me an error. Well, anyway, board, and this is going to be phaser.tilemaps.dynamic tilemap layer. So if there is a tile, don't do anything, can't go there because there's a wall. Find the distance, and then find the min distance. Okay, that looks good. So let's export this. Export, determine ghost direction, export default, And I will also export as a non-default. Okay, so Chase Hero AI. So we're now about to delete a whole lot of code. So import determine, let's do this, from ghost movement. Determine, okay. Sometimes VS Code needs to be restarted. Some of its IntelliSense doesn't work quite right. Okay, that's really all the code we can just delete, and then return this. We're going to give it tx, ty, give it the ghost, and give it the board. And let's just make sure this chase still works as we expect. It does not. Ghost movement. Yes. Oh, it did tell me. Thank you. Okay, not paying attention to the error. There we go. So it's going to come down to me. Oh, yes, it is. Run. Okay, so the chase is working. Beautiful. So scatter is the same thing, right? It's just sharing the same logic. Let's just do why is it not? Who knows? I can type it out, I guess. Determine ghost direction and same deal. This is all the same. Return determine ghost direction. Scroll up here, tx, ty. This is the ghost, this is the board. And let's just test it out. Go back here. And we're going to just use our scatter AI again. So that's scatter to the top left. And there he goes. Okay. So you can see we just deleted a whole bunch of code, and we can share all that. So now this is 2 lines for our pick direction for the chase hero. Okay, so you got that. Now let's implement Pinky's AI. So Pinky is the pink one, and that's the pink ghost. So what Pinky does is it picks, I believe, 4 tiles. Let's just count. 1, 2, 3, 4. Yeah, it should be 4 tiles if I remember correctly. It picks the tile 4 tiles in front of Pac-Man. So if Pac-Man is facing right, like it is here, it is 4 to the right. Pac-Man is facing up. Well, let's not talk about up yet. If it's facing left, it's going to be 4 to the left. If it's facing down, 4 below Pac-Man. Now, in the original Pac-Man, the way these vectors were stored was as one 16-bit number. And then each of the, components of the vector, x, y, were each 8 bits. So the whole thing was 16, each component was 8. But because of the way it was set up, and you can watch this video that explains it more in depth, that when it does the up vector, it actually has an error where instead of, when it adds it to wherever Pac-Man is, instead of being up 4 from Pac-Man, it is also -4 on the x axis. So that's why it's up here. So the question is, should we implement the original Pac-Man AI or actually have it as it was intended by design, I think, that it would be exactly 4 tiles in front of Pac-Man pointing up. We're going to do both. So let's make here, we're going to call this Intercept. So we're calling this Intercept because it always picks the position 4 ahead of Pac-Man, and then Blinky is Pac-Man itself. It's chasing Pac-Man directly. So this is going to be the Intercept Hero AI. So Intercept Hero AI. Nope. Export default class Intercept Hero AI implements Ghost AI. Yep. Great. I don't like semicolons. And let's just go there. Again, we got to implement these 3 2 properties, 1 method. So let's just do the minimal implementation here. Okay. Return 100. And then target position we will have to calculate. But for now, x0, y0. Okay. So we know we need a constructor because we know we need the hero, and we know we need the ghost, right? Yes. Yeah. Let's just say ghost, and then hero, and then we know we also need the board. Phaser.tilemaps.dynamic tile layer. Okay. Private ghost, which is my ghost, private hero, not hero AI. Private board is phaser.tilemaps.that. Okay. This dot ghost, this dot hero, this dot board. So here we go. So const xy, not const, let this dot hero dot body dot position. Okay. So we're just gonna send back xy. So now we want 4 tiles in front of wherever Pac-Man is. So let's see, can hero dot facing vector. So our hero class has a facing vector, which gives us the vector, gives us, based on which way it's facing, the vector representation. So if it's facing right, it would be x1, y0. So call that as the facing vector. And so we need 4 times the tile size. So x is going to be x plus vec.x times 4 times tile size. Right, so if it's going right, it's going to be 1 times 4, and then add that to the x. And then y is the same deal, vec.y times this here. Okay, return that, and then down here, x as tx. So this is object destructuring. We went over that in the previous 2 videos, so do check those out if you want an explanation on how that works. And then we're going to take this determine ghost direction function that we just created, take tx, ty, takes the ghost, takes the board. So this handles ghost movement based on the target direction, the target position that we want, that this ghost selected as its target. Okay, so we see here we're not doing the mimicking the original Pac-Man. So let's just see how that goes first. So we don't need direction anymore. Okay, let's go back to game. And now we are going to import our, what do we call this? Intercept. Intercept hero AI from game, new ghost AI intercept. So let's comment this out. So ghost.setAI, new intercept hero AI. We're going to give it the ghost, the hero, and the board. And trust me, it exists. So this is the TypeScript non-null assertion operator. Just it lets you tell the TypeScript compiler, trust me, this is not going to be undefined when I use it here. Okay, let's go back to our game. So this is aiming for, yeah, so the front of Pac-Man. Oh, let's seem to have gone an unexpected direction. So let's draw the actual position that we think it's supposed to be, so we can like double check ourselves. So in our new ghost, you can see that our has this enable target marker. So let's just actually do that. Let's see. So scene.add.text. We're just going to use a very simple text. It doesn't really matter where. And then it's going to be X. And we're going to actually save this as a class property. So private, I'm going to call it text marker. And it's a phaser.gameObjects.text. Okay. Oops. Okay, so this .text marker. So enable text marker. Let's just say .set visible. By default, we'll save. So now what am I going to do this? This .enable marker will just do false there. And so that this .text marker .set visible enable. So it starts off false, so we don't see it. And then what it does is when we pick the AI behavior is going to do that. So pick direction, that's actually after it's done all it's going to do. This .text marker .x equals to this .ai .target .x. We'll do the same for y. Well, it's going to be slightly more efficient if we do this. MX. So this is basically, I'm saying marker X, marker Y. Okay. And so no marker because we need to enable it. So ghost dot true. You see there's the target marker right here. So it's clearly not right. Let's see what we did wrong. X, Y, 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 let's see. Let's think. So it's facing a vector should be -1, 0. Let's put a debugger. For the debugger, then let's bring up our intercept hero AI. Put a thing here. Let's see. Hero body position. So that's where we are. Where's my... Let's move me. Here's my controls. Facing vector is -1. Okay, yes. So this is not exactly... So what you see here is actually this value is so close to 0, it's basically 0. So what we can do. So we already know that if x is not equal to 0, that we are going to adjust x. And then else, we're going to adjust y, I think. Am I saying this right? Let's see. Don't need this breakpoint. No. If x is not equal to 0, let's see here. So we have -1, so it does that. And it doesn't have to do y, but that's not true. Let me just check for something. I had a more clever solution to this. linear direction is what we mimic, so we don't actually care about that. I guess we could have done it this way too, but that shouldn't matter. Okay. I guess I didn't solve it any clever way. Okay, so if it's facing left, so we know that we could also do this. Dot, we don't want to. If, I don't believe that it didn't have a better solution than that. Chicks. Intercept. Flank. I guess it didn't. Alright, so we gotta actually do some thinking. So the y is basically 0, but it's just the way we're calculating we're doing this. We're using vec.set to polar based on the angle that it's at. And the result is just not exactly 0. Right? Or am I actually just being a dummy? So this is going to be 0. So y I could be being a dummy, actually. Let's see. Let's see. I shouldn't have to do this. Let's also make sure that I didn't ghost mx and y. Okay. That should be right. See, this clearly is not 4 above. I must be doing something wrong here. So I mean, okay, realistically, I should do it this way. I change the magnitude of the vector, and then I multiply it by tau size, and then I add it. We're still not what I'm expecting. So now that's very far. That's definitely not 4. Let's check. What the facing vector object is 6. Oh, but this is very close to 0. Right, so let's see. Times 4. Let's go to the console here. I believe this works, right? Yeah. So what is this? Yeah. Right. That doesn't exist. So you can, in here, basically run code based on the current context environment that it's in, so you can access the variables here. It's sort of cool. So we times 4, and then we know that's 32. So what exactly is this number? So parse int 7. So it's facing down, and yet my x is vec.x 6. Did I not do this? I'm a dummy. I thought it actually gave me back a normalized vector. Well, I mean, that's still wrong, but God's green earth, what's going on here? One, zero. Okay, let's see. So it's facing right, 1, 0. So why is it down here? The math is clearly wrong. So 4 tile spaces ahead. X is x plus vec x times that. How is this? Must be doing something wrong, but this made sense to me when I wrote it the first time. Let's see. So 1, 0, that's right, so that's still in the wrong place. 1, 0, x to 8, 5, 12. So this is, of course, 1, 2, 3, 4, so that's right. Y, 5, 12, 5, 12. This is 5, 12, that sounds about right. Step over. X is now 416. It was previously 288, but that seems correct. Y is 512. Y plus 0 times. Oh, what? No. Maybe just find this. Okay, let's see. Y is 512. And it returns that. Y12, that's right. It's the second time and it is still correct. And now this is in pre-update next. Okay. And what? 512, 416. But that is clearly not. Because X, let's see, do I have body position X? Y, 256. This is the ghost. I don't have access to the hero over here. But this is 288, this is certainly 512. And so the monster's not drawing in the right spots. Okay. Let's see where our issues is. Ghost. So if we don't do this, did I put it in the wrong place? Scene.add. So currently this X should be at up here, but it is not. That is not 0, 0. Scene.add text. Set origin path. I mean, that shouldn't account for this gross. No. Well, that is better. So there we go. That actually might. I think maybe line height or some other thing will fix that. That's closer to 0, 0. Okay. Let's go back Ghost. Here we go. Right, so that's great. It's still not quite perfect, and let's just go back to my previous. So yeah, see, there's nothing that I did particularly different. Okay. We do want the depth to be set depth. We'll just go with 1000, so the top of everything. All right, so you see this is the target that the ghost is aiming for. So, right, it's going to go that way. So we can see. So it should go, I think, left. Yeah, and then up. Based on that logic. Now, for that Pac-Man bug, what we can do, let's close ghost. What we can do is, to make it more like Pac-Man, we can do, so if it's going up, so this is only an issue if it's going up, so that's -1. We can do, the x is going to be -1. So if it faces up, we're going to actually also face left. So let's check that. There it is. So instead of over here, now it's over here. This is more in line with the way Pac-Man actually works. So now this video went longer than I expected due to this bug here. But that's what happens when you're coding for real. Some unforeseen issue is going to trip you up for no reason sometimes. All right, so that was the Intercept Hero AI. That was Pinky's AI. Come back for the next video. We are going to look at Inky's AI, which is a slight variant. No, just went through the wall there. A slight variant. We can fix that because we're not wrapping, so you see the ghost is not going around. As the Inky's AI is a slight variant on Pinky's AI. So come back for the next video.